So this is going to be our notes. This will be fair game when we get to the test later. And what we're going to do is we're going to just start out with understanding some of the words that get used in polynomials. So, one of the first things we'll talk about is what a degree is of a polynomial. And the degree, not like the temperature as much, but you cannot have a negative exponent or an exponent in the denominator when you're doing these, okay? If you do, if you get one of those situations, it's actually not a polynomial anymore at that point. So that's kind of our danger portion of this, to see if we even have to even deal with doing the rest of it. Because if that part isn't true, you know, we don't have to worry about the rest of it at all. So then we get into all these different types. Now, one thing I didn't mention on here was a monomial. I'm actually going to write that in here. I'm kind of surprised that I didn't do that. So a monomial, what's mono mean? Mono is one, okay? So if I have a monomial, that's only one term. So I don't see any pluses or minuses when that happens. I may have something like 2x, or just a number like -4, or something like that. One term, I don't do the plus or minus thing. As you start to get larger, though, binomials means there's two, and now you start to notice there's a plus or minus in the middle. Here's the way I kind of like looking at it. That plus separates my terms from each other. So basically it means like, well, so x is a term and 3 is its own term. So I've got one here and one here. Or 7's a term and 3x is a term. That plus or minus kind of acts as my wall between terms, so I can count them up a little bit easier. And as you continue to get larger with your polynomials, like try is 3, again, and I can notice that because my plus or minuses kind of act like a wall and let me know that there's 1, 2, 3 terms here. So just let that kind of be your guide. Once you start seeing pluses and minuses between stuff, that's how we're going to figure those out. And if you get ones that have more than 3 terms, 4, 5, 6 terms, we really don't use special names with those. We just call them polynomials at that point. You know, terms that have many, poly just means many terms. So, let's kind of come down. I'll come back up here to degree in a minute. I'm going to come down to this chart. And I want to work on this first column first. When it says polynomial, it just means which of the types is it going to be. And that's all I'm really thinking about when it comes to this part. But the one thing I do need to do before I start figuring out which type it is always kind of run it through this test and make sure that neither of these things are occurring. That I have a negative exponent or an exponent in the denominator. Because if either of those things happen, I don't even have to do the rest of it. So let me kind of just scoot down here a little bit. So if I look at number 1, do I have any negative exponents or exponents in a denominator? Let's see. What's the exponent on all these variables when I don't see one? 1. So that's positive, so that's a good thing. I don't even see a denominator. There's not a fraction here, so I don't have to worry about that. So this one's good to go. How many terms do I have in number 1? 2. Because this minus that's here is like my wall of sorts. So I have 2 terms, and what do we call one of these with 2 terms? Binomial. Yep. Binomial, just like a bicycle. 2 wheels, 2 terms. Number 2, don't see a negative exponent. Don't see any denominators at all. How many terms do I have here, though? 1. So what do we call the one-termers? Okay. Monomial. So one term we've got mono. One term we have mono. 3. Exactly. Okay, here I have a negative exponent, so it's not even a polynomial, so I just kind of put a big line through it. I can't do anything. It's kind of like when you see something that's you know it's no solution right away. That's kind of what this version of this one's going to be. Now here's one thing we haven't talked about though as far as the polynomials go. Because number 4, you're looking at it first and you're going, ooh, that's polynomial for sure. Look at all those terms. But stop for a second. Are any of those terms alike where I could put them together? If they are, I need to do that first. So like here, I got 4x, another 1x, and this 2x that I can put together. So let's see here. I've only got one term that has a third. How many x's do I now have? 7. I got 4 and 1 and 2 more. I'm not multiplying here, so don't mess with the x. Just put that number that's in front. So 4 plus 1 plus 2 gives me 7 x's. And then I got this 4 left over. Okay, this is called the simplified form of my polynomial. Now I can figure out what to call it. Yeah, so here I've got walls with this plus and this plus, so I have 1. What's that? Because once I see here I have 1, 2, 3 terms. So once I have 3, that tells me that it's going to be a trinomial. So that's how we figure out what type of polynomial, or if it's even going to be a polynomial when we're working through it that way. Now, the next part, oh, I guess I was just supposed to put yes and no in the first column because we took care of the next part here already. Woohoo, okay. So degree then, okay. The degree of a polynomial is the largest sum of the exponents on a single term. So there's a little bit of math work to do here. A little bit different before than when we weren't combining exponents. We're still not, but within each of your terms, okay, before the plus or the minus breaks them apart, add up the exponents in each part and that'll be your degree. So for my first term here in this next example, what's my degree going to be? Okay, 5, because I add the 2 and the 3 together. And I'm just going to mark this down for each one to kind of as a reminder. What about this middle term? What would my degree be? 3, because I remember, oh yeah, there's a 1 on that x. So 1 plus 2 is 3. And then the last one's going to be 6, because it's 3 plus 3. Once I do that for each of the terms, the degree for my entire polynomial is just the biggest one of those numbers. So in this case, my polynomial's degree is 6, because I just find the biggest single one. And then just a note up here too, if there's no variable, that means my degree for that term would be 0. So if I just get a plain number, my degree will be 0 on that. Yeah. So when we get back down to the problems that we were working on before, now the only thing we've got left is to figure out what their degree is going to be. So let's see here. take a look here. I got my two different terms. Which one has the bigger degree, and what's it going to be? It would be 3, because this one has a degree of 1. It just has a 1 on the x. But this one has 1, 2, 3. So my degree is just the biggest sum of my exponents. What about number 2? 0. Yeah, the second one's 0. If I don't have a variable anywhere, it's 0. If I have any variables, it'd be at least 1. Number 3 we can't do, again, because we had that negative exponent, so I just kind of wiped everything out. And then this one, right. My first term has an x to the third, so that one would be 3. This one's just got an x, or an x to the first, so it would be 1. And that one would be 0, because I don't even have a variable. So 3 is the biggest one this time. So that's kind of all together what's, going on with these. However, we need to get a little more practice in here before I set you off on your own. So determine in each of these whether it's a polynomial or not. If so, tell whether it's a monomial, binomial, or trinomial. Okay. Actually, let's look through these 6 in this section first. There are 2 of those 6 that are not polynomials. Which 2? Okay, why 6 and 9? You're right. Yeah, once I see that exponent in the denominator of a fraction, those 2 are done. You cannot have an exponent in the denominator and still have it be a polynomial. So if the other 4 are, then we should be able to figure out how many terms there are and how we would label those. So this first one looks like I only got 1 term. Yep. And if you guys just want to write the first part of that to shorten it up a little, that's okay. What about number 7? Yep, I was going to say, be careful. Because I have like terms, yep, that I can put together first. Once you've totally simplified it, then you can make the determination of which type it's going to be. So there I got to be careful, because I might have written trinomial, but really it's only a binomial. So let's see. In number 8, can I put those first 2 things together? Nope, they're close. I know they both have a g and an h, but this one's got a g squared. It makes it a little bit different. So nothing to combine, so how many terms have I got? 3. I got 1 here, and then I got 1 here, and then I've got 1 here. So 3 terms makes it trinomial, like a tricycle or a triangle. We already said 9 was a no-go because we have an exponent in the denominator. And then 10, yeah, I can't put these together because this has x and this has x squared, which means I have 2 terms, so I have a binomial. And that's all there is to labeling these. Combine any like terms, check for those couple of bad things that can happen, and otherwise you're ready to go. Find the degree. Add exponents on variables. Only on variables. So actually we get one that's a little bit challenging here right at the start. If I add up my exponents on my variables, what's my degree going to be in number 11? Okay, 6. Because I'm just adding up those exponents that are there. And then I just got to keep reminding myself, if I don't see an exponent, there's a 1 there. So what's my degree in number 12? 3. Now I'm going to skip one for those of you that are going part by part here. What's my degree going to be on 14? Yeah, if they're the same, we just use that one. So you're like, well, what do I do here? Because each of my terms has a degree of 1. Okay, I can't put those together and call it 2 because there's a plus in the middle. Those terms are separate. If they're the same, that's okay. We just use the biggest one, which in this case is going to be 1. Because we're only taking the degree per term when we're doing these. So let's take a flip over. I want to find one that'll be a little more interesting here. Let's take a peek at numbers 18 and 19 and 25. So yeah, we're just trying to find what the degree is going to be. So let me just kind of separate those off. Which one of those terms has the biggest exponent when we add them together? The first one, and it adds up to 5. 3 and 2 would get me to a degree of 5 for my first. Here, 1 and 3 only gets me up to 4. I want the biggest one every time. So we're good on that one. Sure. 16. Okay, we'll separate down here. So I got 2 on my first one. I got 1 y and 1 on my z, so I got 2 on the second one. And on my third one, I've only got a 1 on the y, which is 1. So I only take the biggest one I see, which would be 2 from either of my first 2 terms. Either one of those works.
You don't have to add all the 2's together.
Right, no, because you only find degree from your exponents on a single term. So once those terms separate with plus or minus, we start over again. So like if we were doing 19 then, okay, what would be my degree on the first term? 12, I'm just adding exponents. Just keep telling yourself I'm adding the exponents. My second term would be 2 plus 1, or 3. Yep, and then my last one is 7 plus 6, which is 13, and I only want the biggest one. And that's my biggest thing on these. Bless you. And again, just keep reminding yourself, so like if we were doing 25, that if you don't see an exponent, okay, yeah, the last one's 0 because it's just a number, so I just take that biggest one. Yeah, these are in the same term, so I'd still add their exponents together.
So you couldn't add that to the 9 ABC?
Nope, because that plus or minus separates these. It's kind of like a wall getting built. So actually, this last one here, that just has a single exponent, but it's a 5, is going to be my biggest one. Sometimes I've even gone so far as to take a highlighter and wherever I see the plus minuses, put it in to kind of remind myself, almost do something like this, to be like, okay, that's where they separate. That's where I got to quit counting, because I can't just count them all up, because it doesn't quite work that way. Any others that you see up there in 15 through 26 that you see could be problematic? Because I want to make sure we've got that good before we do this last thing. Which one?
42, because it doesn't almost do with that. Would this be 2?
It would, because this one's got 2, and if it's just a plain old number, that would be 0 actually. So yep, that one's going to be 2. Absolutely. Any others up there?
So the number 15 goes to 0.
Yep, 15 would be 0. Absolutely. No variable term, 0. So the last thing we're going to do today then is writing the polynomials in what's called standard form, which means you're going to go from the greatest degree to the least, or like we put in here, the biggest to the smallest exponent. So when I go back and start looking through here in 27, my biggest exponent's 2. So I start with x squared. Yep. And then next would be my 5x, and then would be my 6, because my degree goes from 2 to 1 to 0. Okay? Any plain numbers you have will always be at the end on these. They will never be at the start. And I just have to make sure I take my signs with me. It's like 28 can actually be tricky.
Yeah, I'm confused. I didn't know if you put the minus first, like the negative.
You would. This minus or negative is attached to whatever's right after it. So 28, I would actually start with negative 4x squared.
Is that all you do?
It's true.
So all you do is just write them out. Okay.
And then, yeah, for here, we're just writing them out. And then there's one other thing that's being asked for, but you're going to like this. It's simple. It says identify the leading coefficient. Well, what does that mean? Once you put them in order, whatever number's in front of your first term is your lead coefficient.
You just come in order like 29, 52, and then 3 and 4.
Yeah, except you always want to go from biggest to smallest.
So it's just like that.
So it's already in the right order for us. But like, for instance, on 27,
1 by 1.
yeah, I was going to say, if you don't see a number in front of your first term, my lead coefficient would be 1. In 28, again, once you put them in order, not before, would be negative 4. So we put them in order, then we do it that way.
So it's basically just some that comes first.
Yeah, because like 29, that's already in order. Don't really have to do anything. But what would my lead coefficient be?
1.
1. Oh, let's see. Where's one that could be interesting?
Like on 30, you put the 3 and 7 and 3.
Yep. On 30, we'd start with 3x to the 7th because that's the biggest degree. What would be next?
The 2.
Yeah. And if I don't see a number in front of that, we'll assume that's a plus. So biggest exponent to smallest. And again, my leading coefficient is just the number in front of my first term. Let's see, any others down here look troublesome? What about 37? What would be my first term in 37? Yeah, negative or negative 1 x to the 8th. And I'm actually glad you put that 1 in there because it's going to make it easier. And then my leading coefficient, right, it's negative 1. So yeah, if you just see that negative or that plus sometime, we just assume a 1's there. And we're ready to go.
I thought you were doing the biggest.
We always go biggest to smallest on the exponent. Sure. All right, so let's look at our exponents here. Which one's the biggest exponent?
I thought 9 was the biggest too.
Well, but you're looking at the exponents, not at the numbers in front when we're trying to figure out the order they go in.
9.
Yeah, but my exponents are 2 and 4 and 1. So yeah, the 9x to the 4th would go first, but because of the exponent.
Oh.
And then next would be this one because 2 is my next biggest exponent. And then that would be my last one.
But if it was like, let's say the 9 had like a 2 and the negative 2 had like a 4, then
Uh-huh. Yep. And then my lead coefficient would just be 9. Because once I have them in order, it's the number that's in front. But I got to make sure they're in order first. Any other ones that look like fun?
I'm sorry, so like, you have to like set it up, I can just let the answers just.
Well, I mean, on these, sometimes you'll have them like on 29. If they're already in the right order, you can just be like, whoop, that's already in the right order. Just tell me what the lead coefficient is. But otherwise, yeah, I got to put them in order from the biggest to the least because that's part of what we're trying to work on down there. So, as you come off of this sheet and onto the homework, I just want to put this up to make sure that we're doing things the right way. So here, it says find the degree, and then write the terms in descending order. In other words, write them in standard form. So like if I was doing number 2, first things first, what's my degree going to be for number 2? What's the biggest exponent on a single term we see? 5. And once I have that, we're going to write it in standard form. So you start with the largest degree term first, which is negative 4x to the 5th. What's the next one down in order as far as degree goes? Yep, negative 2x to the 4th. Good.
And once you put the x in it,
Yep. If you ever have a plain old number, that's always got to go last. Because it is a degree of 0.
and so the degree is bigger.
The biggest exponent. Yep, the biggest exponent that you see. So, okay, thank you. So next then, here, once you figure out if it is a polynomial or not, and you will have 2 of them in this section of 1 through 6 that aren't polynomials, you're just going to say yes or no if it's a polynomial or not, and then say what type it is. So, for instance, if we were doing number 2, let's just stick with number 2's here. Is that a polynomial? Do I have any exponents in the denominator or any negative exponents? No. So this one's a polynomial. And then here, good call. Because I look at that first, I'm like, wait a minute, binomial looks like a trie. But remember, these both have a by. So I can put those together. Then I determine what type of polynomial it is, if I can put something together.
Is it 4, 0?
4 would be one of our no, Hardy, no. Oh, gracious, you're smarter than I am on this one. So here, is it a polynomial? Yes, because I don't have a variable down here, it's just a number. See, I almost fooled myself. And then how many terms do you have? Just 1, because I don't have any pluses or minuses here. That one was tricky. That one just about fooled me. That's bad when it fools me. So then, I wish I wouldn't have put 1 on the bottom of the sheet, but when you get to 7 through 12, we're back just looking for degree. We're looking for the biggest exponent on a single term. So like if we were doing 10, my degree would equal 3, because that's the biggest exponent I've got on a single term. And then the last part's just like what we did in the last part of the notes. Put them in order from greatest to least with my degree. That's what standard form is. And then once they're in order, write down the number that's in front, but not until they're in order.
Number 7 would be 0, right? Or 1?
Yes, no, 7 would be 0. Yep, if there's no variable term, your degree is going to be 0. And then tomorrow